So in Python, pandas is a very popular library, especially in data science to manipulate data. So in pandas, there is a very important data structure called or an object called data frame. A data frame in a nutshell is like a table. You can think of it like any table that you draw or like an Excel spreadsheet, right? Pandas data frames are extensively used across data science to do simple operations on data, right? So now what we'll do is we will load the data. So let's see some simple code. Here I'm importing pandas as PD, and in this folder I have a data set called weather underscore data.csv. Now CSV stands for comma separated values. Comma separated values. Now what does comma separated values mean? It means, imagine if I have a table like this. Imagine if I have a table like this, where my first row is A1, A2, A3, A4. My second row is B1, B2, B3, B4. My third row is C1, C2, C3, C4, so on and so forth. Now, when I store this table as a CSV, the way it is stored is as follows. I have A1 separated by a comma, A2 separated by a comma, A3 and A4. So my first row here becomes the first line in my file. And each of these columns are separated by a comma. That's why it's called a comma separated values. Each of them is a value, they're separated by a comma. Similarly, in my next line in my file, I have B1, B2, B3, B4. So this is my file. This is literally my file, my CSV file here, right? So CSV files are extensively used in data science to simply store data in a very easy to store format, right? Now in this folder, we have weather underscore data.csv, which has some data. Now if I want to load the data that is there in the CSV file into a data frame, all I have to do is pandas.read_csv. It's literally one line of code. And now when I see the data here, I basically have 6 rows of data here, and I have 4 columns. The columns here are day, temperature, wind speed, and event, and I have 6 rows corresponding to 6 individual days. Now this is one way. So here what we are doing here is we are taking a CSV file and we are using pandas read CSV command, right? Read CSV function to read this into a data frame. There are other ways to construct data frames. For example, one such way, there are many ways to construct it. One such way is I can simply say, so what I have here, each of them is a tuple. Each of them here is a tuple. And I have a list of tuples because this shows a list, right? I have a list of tuples. Now I can construct my data frame saying that I want to construct a data frame using this list of tuples with these as my column names. And it will just work but here you'll have to list all the data yourself manually. You can't read it from a file here, right? The one thing that is often done is people store all of their data in a CSV file and they load it to a pandas data frame. That's a more commonly used approach of loading data into a data frame. But you can also do it from a list of tuples. That's perfectly valid. Now the other important parameters of a data frame are, so if I say df.shape, it says that I have 6 rows and 4 columns. The other interesting function is df.head. So what head does is it prints the first few rows in your data. So here it's printing the top 5 rows, right? Similarly, there is a function called df.tail, which prints the last few rows in your data. And these are used, so your head and tail functions for a data frame. So those of you who have done Unix programming or Unix shell scripting will understand the functions head and tail, right? Head and tail are Unix commands literally, and data frames have borrowed the same terminology here. And these are often used to just look at the top few rows or the bottom few rows in your data. Now the other interesting thing is, how do you slice your data? Suppose I have my data which is 6 rows and 4 columns. Imagine if I want data from second row, I want data from second row and fourth row. Okay, between second and fourth row, right? I can just say df2 column 5. It will take the second column, the data for the second row, the third row and fourth row, but not the fifth row, right? Similarly, I can say df.columns, and what I get is basically I basically get a list of columns in my data table. Similarly, if I want to pick one specific column, there are 2 ways to pick one specific column. I can just say df.day because day is the name of a column, or I can say df within square brackets. I can give the column name, and this would return the same thing. Both of them return me basically a new data frame with just one column, right? So now if I want data from two columns, right, not one column but two columns, then the syntax goes like this. If I want data from both column day and column event, this is how the syntax looks like. So now I get a new data frame now, which has 6 rows but only 2 columns instead of 4 columns, right? So now again, this is an example to get all the temperatures, right? Now if I want to find the maximum temperature, right, all I have to do is I have to say df temperature. Now this gives me a new data frame with all temperatures, and I'm just computing the max of it. Similarly, I can compute min. There is another function called describe, which is often very useful in data science. So when I say df temperature, now I'm operating on only the temperature column of my data. When I say describe, it says that there are 6 values and the mean or the average value is 30. The minimum value is 24. Standard deviation, 25th percentile, 50th percentile, 75th percentile are all statistical parameters. Those of you are interested to understand these, please check out our Applied AI course. Please check out our appliedaicourse.com. So there are a bunch of free videos where with the title Exploratory Data Analysis, where we explain what each of these percentiles mean, what standard deviation means, and things like that. You also get max, right? By just running one command, you get a good idea of what the data looks like. So quickly I can say that my minimum temperature is 24 degrees and my maximum temperature is 35 degrees and my mean temperature is 30 degrees, and I have 6 values here. Right? Very simple. Within one line I can get a good sense of what are all the values and what types of values are there in a given column. Now here is an interesting thing. Imagine if I want to select the row which has the maximum temperature. How do I do it? First I say df.temperature.max. Right? This will return me the maximum temperature. Now if I say df.temperature equals to the maximum temperature, this returns me the row number of that row whose temperature is equal to the maximum temperature. Now here I am saying df within square brackets. So this returns me the row with maximum temperature, right? So this is like, you see, remember we are using df thrice here. Okay, this one we are using to compute the maximum temperature. This one to say which row has this maximum temperature, and now to get the actual row itself, right? Similarly, if I want to get only the day column of the row which has the maximum temperature. Now this gives me the maximum temperature value. This gives me the row with the maximum temperature. And for this row, I want to find only the day column, right? And this is how you do it. And you get the value that 1/2/2017 is the day on which I have maximum temperature. Now these are very, very elegant and simple operations that we can do to do some simple operations like this. And data frames are super popular nowadays. It's data frames, and pandas specifically is something that most data scientists and machine learning engineers use extensively when they use Python. We use pandas data frames extensively in this workshop. So and they're super popular. We'll see more code of using data frames in our actual workshop code itself.